All right, I hope everybody's got their coffee today because I definitely do. Ooh, did I remember to do the pop-out chat thing? Let's find out. Pop-out chat. Overlay URL has changed. That's what that. I don't know why it changes. I need to build my own one so that the target overlay doesn't change for comment highlighting or deploy it myself. All right, day 4. We are in. I almost clicked end. The share button should not be that close to end stream. So, what do we have today? A giant squid. Does that say maybe it wants to play bingo? Oh, you know what we should do first, though? I made some adjustments to yesterday's. Let's stash what I have here because I did additional stuff. So I made some changes. Yesterday I got rid of ND array in yesterday's solution. So we aren't doing matrix math anymore, but we are doing. Ooh, that was fun. This is going to be. Yeah, okay. The HDMI cables decided to fizzle out there for a sec. So we used the process here, and before we were collecting into a vec of x, and I changed that to be a bit vec, and the same bit vec that we're using all over the place everywhere else. Hey Ben, how's it going? Good to see you. Welcome to Saturday. Anyway, like I was saying, we collected this into a vec of vex yesterday, but I collected it into a bit vec after the stream, and that brought down the heap allocation from almost 300,000 bytes, so 300k, down to 95. So I still think there's a bunch of work that can be done here. The file size for the input is only 13k, so even if we look at the current best implementation that I have, it still allocates like 100,000 bytes, when it should probably not allocate that much. I mean, we're dealing with bits. But I did take all the matrix stuff out. I'm doing a couple for loops on the bitvex now, but otherwise it does the whole same thing. So the entire rest of the code down here doesn't do any allocations, but this collect is everything. So I need to dig into that and figure out why. I think these bitvex are getting copied, actually, when we're doing this collect, and that's why we're getting so many of them, or getting copies of them or something like that. So we'll find out. But today is for part 4. Would you create tutorial Solana using Rust? I am avoiding all blockchain technology at the moment. And I have really good reason for that. Because I build Rust Adventure, right? Like I build things that convince people to pay money to learn new skills. And the default state, if you start talking about blockchain stuff, is that you're scamming people. And I cannot afford to have that feeling affect all of my really valid Rust Adventure, here's some skills that you can use to get a job kind of stuff. So that's the main reason I don't do anything on Rust Adventure with blockchain stuff at all. It won't be there. There's other reasons too, but that's the main one for why I don't do blockchain tutorials at all. Let's make this a little bigger. Okay, so copy day 3 into day 4, maybe. CPR, we're in day 3, that's the problem. CPR day 3, day 4. And I think about that kind of thing a lot, actually. Like, which technologies do I pick to cover, and which ones do I not? And it really comes down to like, what do I know verifiably is actually going to help people, and what is actually going to what has provable results, and the other side of that is kind of like, when I say this is good, I need you to believe this is good, right? Kind of my entire income is based on the fact that my word is trustworthy. Like, you can listen to me when I say things. So I can't do things like get involved in a large scam, or take a bunch of money to start selling you like a specific technology or something like that, right? Like, even the people that do take money to talk about certain companies or technologies keep it very explicitly separately. Like, if you look at the bigger YouTubers like MKBHD and Linus Tech Tips and stuff like that, they very clearly demarcate where their content starts and ends, and where the ads start and end. So it's something that's very important to me, and something that I think a lot about. And it's very hard to get into the sphere of things that I actually do recommend to people. Let me get rid of all of this stuff, I guess. What is 4? We didn't even read the question yet. So, day 4, giant squid. You're almost at 1.5 kilometers. So deep you can't see sunlight. Giant squid has attached itself to the outside of the submarine. Maybe it wants to play bingo. That's not what I usually do with squids. Bingo is played on a set of boards, each consisting of a 5x5 grid of numbers. So that screams Matrix to me. So maybe we'll go back and use ND array again. I would really like to get better at using ND array. So if I see an opportunity that looks ND array shaped, I want to take the opportunity. Numbers are chosen at random, and the chosen number is marked on all boards on which it appears. Okay, so it's bingo, right? Like 42, and then you like mark 42. Numbers may not appear on all boards, so we have multiple boards. So we have 3 boards here in the sample input. And this is the numbers that are getting called. So if all numbers in any row or any column of a board are marked, that board wins. Diagonals don't count. I love that diagonals don't count. I am very happy. I hope part 2 isn't like, hey, diagonals count now. Submarine has a bingo system. Yeah, okay, we already covered that. And then it just tells us a little bit about what to expect. And then we multiply 2 things at the end, like every other question. Okay, so let's grab this and bring it in. I'm going to drop it into the input over here. Oh, I didn't copy that, did I? Thought I copied it. What are you up to today, Ben? Oh, there's a bunch of spaces in this. That's awkward. I feel like I'm modifying the way this looks. Okay, I'm gonna use a little trick here, I think. Let me do test input dot rs. RS is the wrong thing. This needs to be text. Input dot text. And then we can save this. When I tried to solve part 1, I completely missed the don't count diagonals part and was so confused why my code didn't work. Oh, that's rough. That is really unfortunate. Okay, so this is going to be, instead of doing that and risking having issues, we're going to do this, which hopefully will work. It's a macro. It's not a function. Let me delete all the code in part 2 so that we can actually run our tests and stuff. Let me just delete part 2. I'll just copy paste part 1, move to trash. The lib also is not something we need at the moment. So now we just have the code for part 1. And if we cargo build, I'm going to be doing a code jam with a friend and students on some auth stuff with 11D serverless. Nice. That's awesome. Day 4. I have so much code to write this month. I have the streams every day. I have a contract that I'm working. I have to update the DynamoDB AWS workshop for Rust Adventure with the CDK 2.0 and AWS SDK Rust releases that got shipped at reInvent. And then I have a prototype for Toast that I'm working on. That is like my 4th priority. It's a lot of stuff. Okay, so this compiles. Let's do cargo test. And hopefully it pulls that file in. Am I in the right thing here? Oh no, I fucked up. Copy this. Can you stash a directory? Day 3. All right, we're just gonna stash. Oh well. Rip. I was working in day 3 and not day 4. Okay, that looks like it'll work. So let's cargo test here. Couldn't compile, include stir, no such file or directory. So this needs to be in the bin, I guess. Did I get the path wrong? Perfect. Okay, so include stir is amazing. It allows you to just take a chunk of code that's in or a chunk of text that's in some file and just include it in with your Rust binary. So like this just works, which is really nice. And there's include bytes and include stir, and there might be more, but those are the 2 that I've used the most. So whenever we run the tests, it'll compile this in with the binary and then it'll run the tests. So we don't have to do any we don't have to repeatedly write read file or whatever. What is our answer supposed to be here? 4512. Okay, so we do need to do a read file We read a string on the input. Let's call this test input for now, so I can just like roll with it. And then we need, actually, I don't need to do that. Let's do here. We get the whole thing. We do what? Input.lines, maybe? We could do, okay, so we could do two things here. We could do a non-parser to pull these numbers out. Or we could do like input.lines. I think I'm just going to do input.lines for the moment. Let callouts equal lines.next. Unwrap, because it has to be there. So callouts is going to be the list of numbers. And then I think we have to do lines.next just to skip that. And then if we debug callouts, we should have the list of numbers. What do you even use for, I guess 11t serverless is just like rendering a template, basically. So auth is whatever you want to put in front of it. So we've got our callouts here. We can do like callouts dot split comma and this is going to be the thing that we probably use, so we're probably just going to like down here we're going to iter over this probably, so something like, I don't know, for num and callouts, and then we like just do whatever here. And then we're going to do something in here that's like operate on boards or whatever. It'll be on demand 11D page creation, and auth can be handled by the serverless function. So you, what, you're gonna, so it'll be on demand, which means it's basically static, like basically static HTML, no user auth or anything. And then the authentication is going to restrict your access to those pages. So do you have to do like an edge function to like redirect to make sure that the auth is there? Or are you using like Netlify's auth stuff? Uh, 4512 callouts, cool. So now we need to get the boards. We know the sizes of the boards, right? They're very, very specific. They are number, space, number, space, number. It looks like we do have multiple spaces, so the easiest way to do this is probably going to be with nom and just using like multi-space or something. So maybe we just do go straight to nom, because otherwise I'm just going to have to like grab 5 lines and then hopefully split, because it's easier for me to do this with nom actually. And copy in one of our parsers from before. Parse. Let's do board here. Actually, we're going to need this for part 1 and part 2, right? So let's put it in lib. My friend's built a proof of concept. I'm not sure what he's done yet or how quite yet. Okay, cool. That kind of thing's always fun. Okay, let's get rid of direction. Do pub. What pub? Obstruct board, maybe? I have no idea what we're going to put in board yet. Let's just call it like... Let's call it like a vec of vex right now. And then we'll move it to an ND array after we get the parsing working. So theoretically, if we are at a board, we need input and something. And we need to do what? We need to do like many. So we do need to allocate here. Well, we don't need to allocate here. Actually, we might need to allocate a vec. Actually, yes. I think we do actually need to allocate a vec. Because we need a container. For sure. I've built somewhat of a brand around being the 11D serverless guy. But there's so much I've not explored yet. Super excited to learn more. Nice. It's really I don't know actually. Do you do like independent work or do you do like typically more employee stuff? I will say having a specialty is really useful for both. Let's see, input. Do we want... We probably want multiple parsing functions here. But I think there's many in nom. Let me get rid of... Let's keep one of the ND array things, and let's get rid of basically all of these tabs. I haven't played with 11D serverless like at all yet. I probably should at some point. Okay. Docs.rs, nom, and like there's many and there's fold and there's stuff like that. We know we're going to have 5, right? So we can validate that. Ooh, separated list. Perfect. That could be it. I think that'll be it for us. I forgot this existed. So separated list is a parser combinator that will let us give it 2 parsers and then give us the results basically. So like separated list, let's say we're separated by multi-space. And we need to import both of these or bring them both in. And maybe it's not multi-space. What is it called? It's not multi-space. It's multi-space 1. Let's make sure it's actually not multi-space 1 because multi-space 1, as we can see down in the bottom right there, it says carriage return. We don't want carriage returns here. Because we're going to use the carriage returns for, well, yes, we're going to use the carriage returns to delineate the board positions because we know how big the board is going to be. So I think we're going to use space 1 instead and not multi-space. Import space 1 from complete. And then we will there's alpha 0, alpha 1. Digit 1 is the other one we need. Okay, so this is really cool. This will give us the list of items in our board for one row. There's lots of probably should at some point on the web. Yeah, for sure. My default answer to any new tech is no until I have space and availability and the need to go look at it. I do need to get into a little bit more of the edge stuff is so hype right now, and like it looks like 11T is going to be the only static site generator left after all of the other VC funded meta frameworks all move away from it. Like Nuxt moved away. Next is never really prioritized it. What is it? What's that new one in React? I can't remember what it is. Remix. Remix is server only. Nobody really uses GridSum that I'm aware of. I mean, like, people use GridSum, I'm sure, but like, I haven't really seen people talk about it in quite a while. So let's make that pub fun row input string slice I result string slice vec of string slices, and I'm just going to take this and I'm going to drop it in here. So now we have row that takes input. Oh, I probably shouldn't name this row then. Or defaulting to no until I have the space and availability is the way I go to. Super helpful for scoping what to care about. If I'm curious, I can have somebody introduce me on stream too. Yes, that's one of the really nice things about having like any sort of platform. You can just be like, hey, do you want to talk about your thing and also teach me on the way? Like I know Jason does a bunch of that too. Expected result found tuple. Oh, right, because I didn't handle the error. And then for this, we can do another separated list. And we're not going to put row input here. We're just going to put row. And the separation is going to be new line, I think, is a combinator. Why is that not happy? Oh, because I didn't pass input. So now we have a vec of vex. I mean, look how easy that was. Like, I get that it's not easy if you don't understand. Like, these look scary, right? The type signatures look scary. I totally get that. But when we're talking about like parsing stuff, we get so hung up on like talking about parsers and talking about lexers and talking about ASTs and talking like parsing can be very simple compared to like give me the next character and figure out what to do, and is this a token or what? Like, we can just use functions, combine them, and get rich structs out the back. Board R. These are going to be string slices, which means that we're going to have to put a lifetime on them. It'll be our first lifetime. It's also possible that I shouldn't use lifetimes there, but we'll deal with it for a minute, and if it bites us, then it bites us, and then we'll figure it out. Source bin part 1.rs. We're in part 1, right? Did I put 932 in here already? I did not. On line 46? Line 46 doesn't exist, you silly compiler. Okay, so let's pull in... Well, we need to define this day 4 cargo toml. I always forget to change the package name. And then in part 1, we can do use day 4. What do we call this? Board? Yeah, board. And then here, I guess we should build up the whole parser if we're going to do it this way. Like pub function input, or pub function, what do we call this? Do we call it input and advent of code? Like what's the name they use there? Puzzle input. That's how I was introduced to Figma. I had a friend that said it was worth learning, so I had him on the stream. Yeah, I mean, that makes total sense. Also, Figma is a great piece of software. I love Figma. I haven't learned any Rust yet, so I don't know really how this works, but this parsing seems so much cleaner than my JS implementation, at least. Yeah, there's a way in which, like, when you start doing, like, dot split or you start using regexes, it gets really unreadable. And nom is the library we're using in Rust, NOM. It's a parser combinator library, which means that we get basically a bunch of little functions that we can pass to other functions, which is like what we do in programming all the time. And if you pass the input to them, then you get like the thing you were expecting. So like here we have a separated list separated by at least one space that has at least one digit in the content, right? And now we just have a vec of those string slices, and we're done. This is not going to be, this is going to be puzzle. No, let's make this a tuple. I want to return the callouts, which are going to be a vec of string slices, and I want to return the board. Yeah, so the little braces, or the little angle brackets, are like type arguments. Basically what we're saying here is we have a vec, which is a JavaScript array, and the contents that we have inside of the vec, the items, are going to be string slices. So this is saying basically we have a JavaScript array that has strings in it. And like, it gets a little bit more complicated than that, because this iResult type is something that you both would be unfamiliar with, and you would have to go read the documentation for. But these are just like, these are type arguments, basically. They're like, this type vec uses this type somewhere in its internal implementation. Let's do let input callouts equals separated list. Tag comma, digit 1, input, callouts, board, let input, and then we don't care, equal new line. Because this is always going to be like as we expect it to be. So I think there's just going to be 2 new lines here, which we're just going to throw away. Keep writing input. And then input board. That's probably a bad idea, right? Let's call this boards. That is going to be a vec of boards. And this is separated list 1 because there has to be at least 1. And then so we have a separated list of digits. We take 2 new lines and then we look for a board. We need to look for multiple boards. So we'll do separated list again. And I think I'm just going to name this separator and then call it board. And this needs to be separated list 1, and we'll need a separator function just to clean this up a little bit. Input, string slice, iResult, string slice, unit. Actually, we're not even gonna use this, and we're just gonna do input, don't care. We're gonna basically copy this. And we're just gonna be input unit, and like this just throws it away. So now here we can do actually separate, or because they're all the same new line thing. So now here, instead of doing board, this is the right part 1. Use day for puzzle input. And then this is let input callouts boards equal puzzle input. And we're just going to unwrap this because it has to succeed. And if we debug callouts and boards here with hopefully references, hopefully this works. And if it doesn't work, then I messed something up. Oh, right, I didn't define debug for the board. So I will derive debug. And that should work now. So now we have this structure that comes back with all of the numbers in it. So all of the callouts in order, and then each of the boards, except we only have 1 board here. So I need to debug what I did wrong there. There's something to be said for how these combinators and their arguments are named things in English rather than computery gobbledygook. Makes your code so much more expressive. Love it. Yeah. And we'll see that here when I look through this, and I have to, like, I literally have to go and debug this right now, right? So we have a separated list that looks for the new line, and tries to parse a board, right? So we go to the board, and now we're already scoped in, right? We know we're trying to get a board. We know that we're in the right place because we can see the first row being parsed correctly. So if we do a separated list for board, separated by new lines, looking for a row, we do get this, but we are not doing the separator correctly, as far as I can tell. Because these are not separated by space ones, these are separated by new lines. Right? No, that's the row. The row is separated by spaces. The board is not separated by new lines. The rows are separated by new lines. Let's debug the input here. So we see a new line, and then it can start with spaces. Okay, I think that's our problem there. Right? So this can start with a space. It doesn't have to just be between them. So a row, where's row? Here's row. Input, throw it away equals opt space 1. And this will be input. So at the beginning of the line, we could have a space. And now we have our boards. Did it. I could not think straight when streaming. I tried to change the thing I was iterating over again. Yeah, streaming is tough when you're writing code, especially working with new libraries. Like, I'm about to use ND array for probably the second time in my life in this stream. And ND array is going to be a pain to use. But I'm really happy with the non-parser, right? Like, this is really readable, in my opinion. And, like, when we went to go back and debug our parser, it did not take me very long to figure out where I needed to do a thing, right? And that's because all of this is like semantic, I guess, is the word that you would use. It's very human readable. And we could write a test here too, actually. But we're probably not going to change the parser. So I think I'm just going to leave it. I should have written a test before I wrote the parser, but I didn't. So rip. Let's see. What do we have to do here? We do need each of the boards, right? So we have the boards. But I want the boards to be an ND array matrix, I think. So I need to figure out how to get them into like this shape. Vex are not fixed initializers, as we learned yesterday. Let me look at my code from yesterday and see how we got the... See how we got it into an ND array, because I want a matrix, and we did figure this out, and then I took it out of the day 3 code. That's day 2. I should write better commit messages. Woof, streaming sounds like the right commit. Okay, so array 2 from shapevec. Really random question, what window manager are you using? I am using... Oh, man, if I can not remember this. you buy. So it's Kokishia Yabai on GitHub. I don't know if it's ready for ARM computers yet. There's a tracking issue for ARM computers or ARM Macs, but I am using Yabai. Okay. So now we parse it. I guess we don't really need the input here anymore, right? So I'll just put that as an underscore. Underscore is kind of the Rust thing for like, hey, I'm not going to use this. And then the compiler will be like, okay, you're not going to use this. Great. So we have the callouts, we have the boards. Okay, yeah, okay. I was returning board. We want board to be, we want this to be the array vec, or not the array vec, the whatever it's called. So in this parser, I'm going to do this. I know these are 5 by 5. And we can pull in array 2. And then this, hopefully, I don't know how to type this type. 555? I need to go look up how to type this. Array 2A. Two-dimensional array from. Unwrap feels very hopefully very appropriate for a holiday themed puzzle. You don't have to retract your message, Taryn. Like, you can ask questions. That's fine. Yeah, unwrap is very appropriate. It also panics if it doesn't work, and I like failing really early in these puzzles. Because if we panic really early, we know all the input is like valid, right? It's not dirty input. We didn't have to clean it. We don't have to worry about like user level input. So if it doesn't fit what we expect, fail. Okay, array A, index 2. So do I need to give it like a string slice here, or like? Really random question. I noticed the resizing and spacing of windows in your videos. Are you using a window manager for that? Yes. So the spacing off the sides, like the borders up top and the side here, that is Yabai doing a padding on my entire thing. And then the space between the two windows right here is also Yabai. So the outer space is, I think, double the like window space in the middle. And that's all in a config somewhere. See if I can. So my Yabai RC does like top padding, bottom padding, left padding are all 16s. And then the window gap is 8. I turn the window shadows off because I find it very distracting to have like one window focused and the shadows on when I'm talking about another one in a video. And sometimes I need to overlay like me talking on top of a video that I didn't mean to use for that, to just like explain something additionally. And the shadows really take away from that explanation by taking your focus to a different window. So I turn windows off. And then I use the binary space partitioning like layout method so that if I'm here and I'm like, oh, I need another terminal, I have another terminal. And I don't have to worry about like placing it. I just get, hey, I need a terminal, and it shows up. All right, what's our problem here? Expected string slice found struct. Why did you find destruct? Because those are vecs, is that why? From shape vec. Let's go. From shape vec. An n-dimensional array. The array is a general container of elements, yada yada. From shape vec. So from shape vec, there are words here that I'm unfamiliar with as well, like stride shape. I don't know what a stride is. So this is me learning this library with you. Create an array with the given shape from a vector. For a contiguous C or F order shape, the following applies. If the shape does not correspond to the number of elements in V, or the shapes would result in overflying I size, we have an error. So maybe we have to create arrays before we create the whole thing. We did this yesterday with a vec of x, right? I guess we extended from slice. Oh, that's what we did. Okay, that makes sense. So it's a little awkward here. The construction of these is not something that I'm super familiar with yet, but for call out in rows, is that a better name for this? Extend from slice, call out. Okay, so that should give us our array2 things now. And we can see, if we look at this, oh, this is quite wide. I'm just gonna let that wrap. We can see that we have a board now that it looks a lot more like a vec of vecs almost, but it's not. It's a matrix. So the other thing is that we're gonna have to mark these. So I'm assuming that we can do something like this if we can do string slices. I'm just going to call this mark, and I'm going to do pub enum mark called and uncalled and derive debug, because we're debugging that out at some point. And we have to implement default, which I forget how to do manually. Well, I guess we don't have to implement default, do we? Right, like, where is this? Extend from slice, rows. Rust, vec. Wait, is it a vec? Actually? Yes, it is a vec. Extend from slice. Clones and appends all elements in a slice to the vec. Iterates over the slice other, clones each element, and then appends it to this vec. The other vector is traversed in order. So I think we want to map this first. And then V. Well, if we map this, then we have to collect it. If we collect it, then we just have a vec anyway. So maybe we don't do that. maybe what we do is rows.iter rows.iter dot flat map flat map on the call out, and the call out actually flat map on not the call out, the row dot iter dot map call out, and then we do mark uncalled. And then hopefully we haven't completely busted everything. Expected tuple found mark, because we need tuple and we need call out mark uncalled. We could also make this a struct, now that I think about it, which probably would be better. What do you call a place on a board? Substruct board cell. Num. String and again, these references may screw us up and I may have to change that, but this is board cell now with a num of call out and a called of mark uncalled. I was thinking cell. Yes. Cell is something that I would use, except for the fact that cell is actually a data structure in Rust. So actually using board cell is kind of iffy in my mind. Like if you're doing safe Rust and you are not doing threading and you're not doing a bunch of stuff like that, you actually probably won't know what this is. But there's a whole cell kinds of there's a set of data structures called cells, basically. So calling it cell could be confusing. Square is good. I like square. Board square. Last year you did call it cell? Yeah. Okay, so this is no longer that. This needs to be a board square. And we need to debug it again. Okay, so now we have the whole thing and whether or not they're called. So we have a bunch of boards. They're in a ND array, 2D matrix. I think the matrix stuff is the most complicated part of the parsing. Like all of the parsing is fine, and then the initialization of just the matrix is like, eh. So let's see. We got call outs and boards for each number. What do we actually have to do? Do we just stop when one of the boards wins? The score of the winning board can now be calculated. So there is some kind of thing that we have to do here. So where's board? Board is here. We can enable board and score, which is going to be going to take a self and return us like a U32. Self.board.iter dot what? Filter this board num. We don't care about num actually, so I'm just gonna ignore it. And then, well, we do care about num. We don't care about num in the filter though. I'm gonna forget what I called this field the entire stream. So board num called, and then match called. I don't need the return type. I need the arms of the match, please. Thank you. There is mark called, mark uncalled, and this is and we are going to filter map here. And filter map is going to be, and now we're going to care about num. So this is going to be some num, and this is going to be none. Well, actually, we need it the other way. This is going to be none, because if it was called, we don't count it, and then this is going to be some num. And then we have a problem with some. Oh, you know what? I forgot to convert these to numbers. Parse. We'll make this a U32. And we'll unwrap this so that it works. So theoretically, score could fail. This should really be a result return type. But we're kind of pushing off the parsing until we have to do it. And we're working with string slices for the whole thing. So how does this function feel to y'all? Do y'all want me to explain this? Basically in Rust, you can put functions on structs or like associate functions with structs. And this little piece here is called a lifetime. Because we're passing around references to strings, like things somebody else owns is the way that I'll put that. Like some other kid has a toy and we're like, oh, cool, a red ball. Let me remember that red ball, but we can't like modify it or anything. Then we add a score we associate the function score with board. It takes a reference to itself. So what we're saying here is we can look at board and we can look at what it is, but we can't modify it. And then we're returning a U32. So we're taking the board field, which is in this struct up here, off of self. We're iterating over it. Because it's the 2D matrix, this will iterate over all the cells. To filter out the cells that were called, we use filter map. I destructure the board square, which we defined here, to get the number that is associated with that square and whether it was called or not. Then we use the match syntax to match on that, and we can use our enum, which we defined up here, which has called or uncalled. And if it was called, then it's none. If it's uncalled, then we parse the number and we return it because we need the sum here. Is there a reason not to parse the strings to numbers when you're parsing the board? I just didn't do it at the time. I could totally do that. And probably if we run into problems with the lifetimes and the references, I probably will do something like that, Derek. Because that'll give us like allocated numbers that we own and can copy around rather than string slices, which we have to like point to. I just didn't do it that way for now. So let's do for board in boards debug board.score. So we have a 300, a 324, and a 325 total. So that works. What else do we need to do? The third board wins because at least one complete row or column of marked numbers. So we need to figure out how to check rows and columns for being completely marked. Let's go look for something that's like rows or something like that. Gen rows. Oh, here's rows. Return a producer an iterable that traverses over the generalized rows of the array. For a 2D array, these are the regular rows. Oh, cool. If we had a 3D, could we like go diagonally? Maybe we'll use that later on. Okay, so we have this. We have the rows actually. So does that mean there's a columns? There is a columns. So we have rows and columns. On board, we'll do pub function how do we want to do this? So I have two thoughts in my head. We can either do a detection, or we can write a detection function that's like has one or is finished or something like that. Or we can write a function on this board that will mark the actual cell when something is called. I think that is probably the better way to do it. So we'll do pub function mark, which will take a mutable reference to self and return an option we'll call it an option U32 at this point. So let's do this. To do return, well, let's do pub enum board state finished U32 or playing, right? I'm going to derive debug for this because derive debug for everything if you can. So this is going to be a board state. Why does that have to be wrapped in a result? Oh, because I don't have one yet. Board state playing. So by default, we're playing, right? And then we have to find all of the ones that match each call out and mark it as called. Good luck. I'm going to watch the F1 qualifying. Want to see it before the race tomorrow? Cool. Have a good one. My goal was starting the stream early. Oh, we've only been streaming for an hour. I feel like it's been a long one in terms of like we're still on part 1, but I'm having fun doing NDRA stuff. Multiply the number by the sum multiply that sum by the number that was just called. So we do need another thing here. So right. And then at some point down here, we're going to do self.score times callout.parse u32 unwrap. So that'll be our return value, right? It'll be either one of these two things after we mark. So mark all cells. Check if when rows. Check if when columns. Return one of these. So this is what we're doing. We're marking, we have to mark all cells that match call out. We have to check if we won after we do that on the rows. We have to check if we won in the columns, and then we have to return either the fact that we're still playing, which means that the board is still in play, or we've finished, which means that we're done. So how do you think we mark a cell in NDRA? We could do self.board dot what's it called? Rows mute dot into iter. I don't want into iter. I want, is it an iterable already? Is my question. I think it is. So self board rows mute. Right. For row and self board, do I have my type inlays on? I don't. Okay, so we have a array base here. This is something that I was really missing yesterday. I missed it a lot. I really love Rust Analyzer, and Rust Analyzer specifically using like the type inlays, because it tells me what these are, and when I'm working with a new library, I really need it to constantly tell me which types I'm using. Okay, so row dot iter, maybe I just assumed there was a rows mute. I didn't actually. Immutable array view. So let's go check out what array view is. That's not helpful at all. Let's look for array view here. represents an array or part of it, creating from an iterator, subview, or slice of an array. Array views have all the methods of an array. See array base. Okay, that's cool. So this will have some kind of arc array. That's cool. Subviews. I think we already restricted the axes, so we already can do this. Columns mute, maybe? This returns mutable array views, though. Mutable array view of column index. I wonder what we have here. Row dot we could do something like for I in 0 dot row dot row dot len, and then try to do like a row I, like if row, is there a get? Okay, so there is a get. Return a reference to the inlet index. If row.get I equals call out row.get mute I dot 0 dot 1 equals mark called. That feels real sketchy. No field 1 on type option mute board square. So that'll be our first thing. Fields are called. Right, because I didn't make this a tuple. I forgot. Row.get I.unwrap dot call, no, dot num. And this is going to be okay. Row in self.board, the row is mute. Move occurs because row has type, which doesn't implement copy. Makes sense. Moved here because I messed up. Probably moved again. Cannot borrow as mutable. Changing this to be mute row. That makes sense to me. So now we can do that. I don't know that that's the best way to do that, by the way. It just seems to be a way where the types all fit together and everything works. So now we're outside and we can do self.board.rows dot, was it just rows dot all? And this will be item dot called equals mark called. rows gives us a iterator, right? Returns a producer an iterable that traverses over the generalized array, whatever. For row and a.rows. So is all not a thing? That's probably my problem. I'm probably thinking of all is a thing. Method not found. Interesting though. And if we do iter, that doesn't work either. Maybe we didn't bring in a trait. Because all is a method on iterator. I thought lanes implemented iterator. Rows, lanes. So let's go check lanes. Into iterator. Type item. Yeah, okay. So there's an associated type here for item. I don't think we should need to do into iter. But maybe we do. Maybe we'll do it for now. No field called on type array base view repr board square. Do we need to do the get again? For row in self.board.rows. Oh, wait, no. Okay. So self.board.rows.into iter all. This is a row. This needs to go elsewhere. So all isn't actually what we want here anyway. Maybe find. I probably need to into iter for that find, but I find that strange. And then this is going to have to be an into iter again. I need to figure out why that is. There has to be another way to do that. Okay, so board.rows into iter, and then we're looking for a row where all of the columns have been called. Array-based view repr. I feel like we're not getting what I expect to get here. Like, this, of course, is my lack of knowledge about the ND array crate. Here we go. Rows, columns, and lanes. Producer of all rows. A.rows. Rows.mute, row.fill 1. All methods, rows, mute, columns, lanes. It still doesn't tell me anything about how to use it. And the types are a little confusing, if I'm being honest. Returns an iterator of indexes and references to the elements of the array. Elements are visited in the logical order of the array. See also zip indexed. Does that have the same problem? There we go. So indexed iter gives us what we want. We'll just use that for now. I think these need to be the same level of reference. Mark. Oh, you know what I did? Or you know what I didn't do? This needs to be partial eq, and I'm also going to derive eq itself. So partial equality is the trait that you derive for doing equality on an enum, right? So is called equal to called, is uncalled equal to uncalled, that kind of thing. EQ is a marker trait for saying that mark is basically like a full equality or like a total equality. You can think of partial eq as the kind of equality that we get in JavaScript, where you can have a number not equal to not a number, or like not a number. So specifically, it's not a number not equal to not a number, right? Two things that are ostensibly the same thing are not equal. That's partial equality. Full equality, or EQ, is everything matches. Like if it's the same thing, it matches. So partial equality in Rust contains all of the functionality, and EQ is a marker trait that doesn't actually contain functionality, but contains a hint for the compiler to say, hey, this is a total equality. Let row win equals this. Then we need to do the same thing on columns. I bet you index editor is the same thing here. Okay, so check if win rows, check if win columns, return one of these. So match. See, row win, column win, fill match arms. But let's see. So if none, then we're playing. Right? If some, then we're done. Then we just pick one of these, I guess. So these are all going to be the same thing. So what I'm going to do here is a little bit tricky. I'm going to do that. And then ostensibly this should, if I take this and put it here for a second, maybe I take the type inlays away because that makes it a little confusing. And then here we go. Now we can use row here, no matter which one of them won. So I basically combined the two options into a tuple so that I can match on both of them. If it's the case where neither of them have won, we haven't found the row we're looking for, then we keep playing for that board. If we found one, found the other, or for some reason found both, which is totally valid, like, right? Like, imagine you have the top left corner unmarked, but the entire rest of the top row and the entire rest of the first column marked, and then you mark the top left. They both win, right? You match on the row, you match on the column. So then this is what we get. Then we score, and then we return, and that should be it. So now that we've written all of the supporting code, we do this, I guess. Callouts that find. Does it find? Is there a find map? There is a find map. Okay, so the goal here is we're going to iterate over callouts. I don't know that I want to do this, actually. Applies a function to the elements of the iterator, returns the first non-none result. So if we do a find map, right, and we take the boards and we apply right, so we find map, we take the boards, need to iterate over this. Using structs for this one taught me a lot more about Rust memory than I've had exposure to before. Nice. That's awesome. Did you end up doing something similar to like this kind of thing where you have like a board struct and stuff like that? Also, what did you learn about memory? Call it set iter.find map call out. Where are boards? Boards. Dot itermute board. For board and board. Board.mark. I don't know if you can break out of a for loop, actually, now that I'm thinking about it. This is yelling at me for some other reason, so I'm going to check. Oh, right, the return type. We're just going to return 0 for the moment, so that I don't have to see a giant red squiggly. Mainly, it forced me to actually figure out how to use stuff without needing to clone it, and I had to use lifetimes for some stuff. I used hash maps for the val to board lookup and marking and stuff. Yeah, nice. Hash maps are dope. Yeah, I think this one works really probably best with mutation, right? Doing the marking and whatnot. Oh, you know what? I can't call this final. Call it fin. Fin equals some fin, some winning number. This needs to be mute. Expected an option found. Okay, let's do this. Cannot borrow as mutable. Or can we? Okay, so there's this. Let winning number equals this. And then we do winning number. And we realize that that is not a valid return type. There always has to be a winning number, so I'm going to unwrap it. And our test passed. Does final mean something in Rust? I think it's just a reserved word. So the way Rust does the evolution of the language is it does additions probably like every 3 years. And there are a number of things that they do to make sure that they can make changes in those additions and as the language progresses. So that people don't start using like final, like I just did, as like a variable name. Because if you, so they basically reserve that list of keywords, even if they don't use them. So in this case, if I used final here and they wanted to add something that meant final in a future Rust edition, they wouldn't be able to because they'd break a bunch of like userland code. By reserving that name or reserving a name in some edition, like Rust 2024 could be like, we're going to reserve the word bloop or boop or whatever, right? That would ensure that past that point, nobody uses that as a variable name in their code, which means that in the next version, like Rust 2027 or whatever it would be, they could actually make that do something or make that mean something. So no, I don't think final actually means anything currently in Rust. It's just kind of a way of saying, hey, we reserve the right to do something with this later. Yeah, Rust is really, really, really good about like not breaking your programs, right? Like in JavaScript, something will update and then we'll kind of just be like, oh crap, we have to rewrite a bunch of code. But in Rust, it's very much like there are additions and the compiler actually knows how to compile each addition. So like in Rust or in JavaScript land, right? We've got like ES 2015, 2016, 2017, 2018. We've got 2018 plus JSX. We've got 2017 plus TypeScript and JSX and like all of these combinations. And we don't have like a compiler that knows how to compile those all from NPM packages. But Rust does have that. Rust has the ability to say, this crate uses Rust 2015, right? So we're going to compile it using the 2015 version of the language. And you can use 2018 or 2021 in your actual crate or whatever. And there's going to be no problems there. Read to string, process file, print line. So cargo run been part 1. Yikes. Because I didn't... Whoops. Okay, I didn't even get my puzzle input yet, y'all. I didn't even look. I didn't even consider that there could be any reason that I would need to look at the advent of code input before running my program. I was just like, no, this is just going to work. It'll be fine. Let's get rid of all these debugs. Hopefully this is the right answer. So when we finish something that I would just love to point out is that when we finished the program, right? Like I was just working with the compiler. Okay, this type needs to go there. This type needs to go there. When we finalized the program for the very first time, and I was like, okay, the winning number has to be returned here. Everything worked. It's something that I really love about working with the Rust compiler is that we can just iterate. And then when we actually go to run our program, it's going to be what we expect it to be. So I'm going to compile here with release. And I'll copy this in to our README. Original part 1. And then we get rid of all of this. So we aren't doing super great on the allocations here. I don't know how to work with ND array in the most optimal way. So that's probably a lot of it. But we're looking at 300 kilobytes, it looks like. Did I just change day 3's README? I just changed day 3's README. Why did I do that? Why do I do that every single time? Git reset day 3. Day 4, part 1. And then we're going to stash that. I'm going to rerun the thing so I can get the copy. And then we're going to get rid of day 3. Close day 3. And go readme for day 4. So 300 kilobytes is our allocation. We probably won't get to optimizing it today, but that's fine. I got about 45 minutes left to do part 2. On the other hand, it might be wise to try a different strategy. Let the giant squid win. Let the giant squid win. You aren't sure how many bingo boards the giant squid could play at once, so rather than waste time counting its arms, the safe thing to do is figure out which board will win last and choose that one. That way, no matter which boards it picks, it will win for sure. In the above example, the second board is the last to win, which happens after 13 is eventually called and its middle column is completely marked. If you were to keep playing until this point, the second board would have a sum of unmarked numbers equal to 148 for a final score of 1924. Find out which board will win last. Once it wins, what would its final score be? So we're looking for the score of the board that wins last. So I think, what are we actually doing here? Right now we're doing a find map for the first win. Do all boards win is a question I have. I guess we will just run out of... Let's do this. Let's do winning boards equals vec board, right? Not equals vec board, sorry. Equals vec is of type vec board. Is board the right type? Yeah, that's the right type. So this is winning boards. So remove, there's a remove, okay. Removes and returns the element at position index within the vector, shifting all elements after it to the left. We'll use swap remove because we don't care about the order. So my idea here is that we have the boards. We are operating over the callouts. I don't think that we need to find map anymore. I think we can do 4 callout in callouts.iter. Then we can get rid of fin. We don't want to break here, but we do want to, this is going to be board U32. So boards.swap remove I, let board B equals boards.swap remove I, winning boards.push B winning number. And then I will come from enumerate. And then we get the winning boards.iter .last .unwrap .1. Cannot borrow as mutable because I didn't say it was mutable. This is not a thing. Boards. Okay, this is interesting. We take a mutable borrow of boards to call iter mute, right? And then we want to also swap remove it. But we don't want to do that. So this is actually Rust protecting me. We don't want to swap remove while the iteration is happening. Hey Kevin, how's it going? Good to see you again. This is Rust actually protecting me. This is one of the features of Rust, right? I'm iterating mutably over boards. Inside of this body of this for function, I also wanted to swap and remove. I wanted to remove the one that we're working on and swap the last one in from the end into that position. So this is Rust telling me, hey, that's going to be a problem. I'm doing good, Kevin. I'm doing good. We're almost done with part 2. I just need to figure out how to remove the boards here. I guess we don't need to. We're not finding anymore, right? So we could do .next. Are you optimizing or just finding the last person to win? Finding the last person to win right now. We're in a situation where I have everything written out, and really all I need to do now is write this so that everything is called in the right order. I'm thinking about whether things in my head right now are like, we have all of the boards. We have the callouts being applied to the boards. Maybe we... Maybe we apply them and save them all, right? And then we don't keep the board. We only keep the score, because we don't actually need the board in the end. And then what we do here is let... We are iter muting, enumerating, and I don't want to swap remove here. I need to swap remove somewhere else. Why do I need score? Score or board ID? Don't we need... We need score for the end, right? We need the final score of the board that wins last. So we need to iter mute to call the mark. And then I don't think we need to do this. So we can board.mark here. This gives us all of the boards in Bs. This needs to be mute. Why is that a problem? Found a reference to U32? Really? That's your problem? Oh, there's something else here. I don't need enumerate. And then we do... Ooh, this is going to be awkward. I think we just filter. Boards.filter.iter.filter result iter filter results. We can push the winning number in here and then return true, and here we return false. Into a vec of boards. I missed something here. Board state finished. I'm not iterating on boards, I'm iterating on BS. That's what I want. Well, what did I do here? BS is going to be... what do we do? The mutation makes us hard. We should have written like a step function and just returned all the boards. Right, because all the boards are mutated currently. And our lib function does mark and score, right? So when we map this, we can map this to a tuple. Dropping for the code jam. Thanks for the stream. Yeah, have a good one. Thanks for stopping by. Vec board cannot be built from type of mute board state. Filter map. Some board Actually, no. None. Some board. I've looked at board enough that now board looks like a word that isn't actually a word. Value of type vec of boards cannot be built from iterator mute board. How do I reborrow this board? Board not looking like a word definitely happened to me last night. We should probably just implement clone for now. We can clone the board. We could also keep the iterator around. I feel like that's another option. Is there a reason Vex don't implement copy? Because they're allocated on the heap. So Vex don't implement copy because copy is for things that you store on the stack, basically. Like you should be able to just simply copy the bits around. And copy is meant to be very lightweight. Copy is a lightweight trait, a lightweight action. Anytime you do it, it should just be like copying the bits of a number or something like that. Clone is the heavyweight version of that. Clone is we're going to take everything and make a huge, big copy of it. So I'm thinking I'm going to do this because I want to reset boards to be the next set of boards. The alternative, of course, is, let's see, let playing boards equals boards dot iter dot map board state playing. So everything starts off in the playing state, right? And then in here, instead of doing this and instead of doing clone, that's not board anymore. That's board state. I don't want to add the current return type. I want you to fill out the board states for me. Finished. I don't know why this pop-up is back. I need to get rid of that again. I feel like the VS Code setting for doing that is super unstable. Yada yada. That goes there. Goes there, and then we have that. This isn't going to be boards. This is going to be playing boards. Oh, there we go. That's why I'm blowing up. This is a vec of a tuple of board state, which apparently it's not going to let me do. Boards doesn't need to be mutable anymore for the moment anyway. This doesn't need to be a thing anymore. For mute board state in playing boards .ittermute.filter. Then we're going to take this. We're going to stick it in here. Result equals board mark callout, which is a board state. Mute state. Appropriate, since we're mutating state. We're going to state equals board.mark. Then we don't need to filter map this, because we just never operate on that stuff. We do need to set the winning score though. Value of vec board cannot be built from iterator reference to board state. What is the problem there? We still might need a clone. Actually. Unless we can do this. I don't think that can happen though. Playing boards. We actually don't change that ever, so. Cannot borrow board is mutable as it is behind a shared reference. That makes sense. Cannot borrow is mutable here. So those are already mutable references. Board.mark. Expected a mutable reference to board state. That's not what I want. Okay, we're down to cannot borrow is mutable for board.mark. Shared reference. The board itself is behind a shared reference. So we have a mutable reference to a shared reference for a board, which I don't think we can collect into this like this. I think that's kind of the point. Expected reference found mutable reference. Oh, right. Just need to put my mutation in the right places. Called option unwrap on none value. What am I unwrapping? 40? That's fine. We're not even doing that yet. This needs to be winning boards dot push fin. Why is that complaining? Oh, it's a reference. My bad. That's not right. That's not what we wanted to do. Match state fill match arms fin. This is all mechanical at this point, it feels like. It's just like getting all of the references and stuff in the right spots. Okay. None of them have won because we aren't looping over this enough, are they? Okay. So for call out and call outside iter, for each call out, we take the board, we grab each board as mutable, we filter out the ones that are finished. Are we filtering out the ones that are finished? That's a great question. Nope, I think I fucked this up. I forgot to remove the debugs. See if this is the right answer. The right answer. I don't know when you said tuple. So I don't know what you were referring to, but thank you for the help. Sorry, I missed. We aren't using Fin here, so that it's not debug board. Thanks for the stream. I'm not done yet, Derek. No. Yeah, sweet. So I went kind of coding heavy there for a little bit. Our process function, so we're looking for the last board, right? Our process function uses nom to grab the puzzle input. The boards and the callouts come out of that. The boards we take mutable references to. We map over them because we need playing boards to actually keep the state around while we're doing this. I could have probably exposed that via the board. I didn't because that's not where my head was at, which is totally fine. We keep a vec of boards and board states around, and then we create a new vec for all of the winning boards. So like whenever a board wins, we drop its number here. And we basically update the state to say, hey, this board is finished. Don't work on it anymore. So for each of the callouts, which is each of the numbers that in bingo that are getting called, we grab the board again as mutable. And we filter out the ones that are already finished here. So this is a for loop over the filtered list, not just the full list. And then we use a pointer to set the state, or we use a dereference to the state to actually set the value behind the state and not the variable. And then we mark. Our mark function is our own function, which in here uses an ND array, goes through all the rows for all of the columns and all of the rows, marks any of them that were matching the call out. So all of the spots on our board are marked at this point. Then we use ND arrays rows and indexed iter to iterate over all of the rows and see if any of them are done. We do the same thing for columns immediately after. And then if either of those happens, we return the score for all of the items left on the board. That's what mark does. And then it returns us the playing state. The playing state is an enum that contains the score. So we match on that state, and if we have the score, then we push it into the winning boards. And this way we keep an order of all the boards as they win. And we return that value at the end. So that's day 4, part 2. Hope you enjoyed it. It was not a help, it was just when I destructure values that I forgot tuples destructuring. Yes, tuples destructure, which is really nice. Because then we can just take the one that we need and then throw away the other value. Some of this code is written like code you would write on stream, or like first pass code. So I don't know that I actually want this tuple in here because boards hold their playing state already. So if we just stored that on the board, that would make a lot more sense than keeping it around over here in a tuple. Because the board itself knows when it's done, right? So we could just do this and we could run mark, and if the board knows that it's already done, then it doesn't apply the call out. But yeah, I think that's it for us for today. I don't think I'm going to actually. Let's do the heap stuff. Let's do the heap stuff before we go. We've got about 10 more minutes. So part 2. Because we've used references all over the place, we have not increased our memory usage all that much. So we're looking at 333 kilobytes for part 1. And because we used references, immutable references, and we did all that work, and we kept the structs all had references and things like that, we're only at 336 kilobytes. So it was a little harder to do that, to be clear, right? Like, if you were writing this code and you were doing it as, say, maybe you just learned Rust and you're doing Advent of Code for the first time, I would not use references here. Do not use references. Use capital S string, use owned types. It'll be easier to debug if you do that. And then as you move through Rust and you learn what lifetimes are and things like that, then you can start using references here like this for optimization purposes. I knew that I wanted to do this from the start. That's why I did it. But if I was doing this and I didn't have that goal in mind already, my default is always to use own types. So use the string capital S instead of references to strings and things like that. Because it makes everything a lot easier when something goes wrong. And if you're writing something for the first time, things go wrong a lot. Luckily, the Rust compiler helps us though. How did you parse your input file? The input file is parsed using nom. So up here at the top, I have a bunch of scoped things for nom. And then I have a couple of structs here. Oop, that was not what I meant to do. I have a couple of structs here, like the board and whatnot. So down all the way here, we have puzzle input. If we look at the first call in our process function, we basically read the file in here, and then we pass it to process. Process immediately calls puzzle input and gets back the callouts and the boards. We use nom to do that. So nom is a zero copy parser combinator library that I really, really enjoy using, especially for things like this. So what we end up doing is we define this parser called puzzle input that composes a bunch of other parsers. In this case, we have a parser for the separator. So we have 2 new lines in all of our inputs, right? Let's go check the input for a second. So everything between all of these blocks, right? These are all the callouts, it's 1 line. And then we have 2 new lines. We have this new line here at the right end. And then we have the second new line here. And then we have our board. And then we have another 2 new lines for the next one. So that's what separator is. We take new line, which is a combinator from nom, and we apply it to the input, and we just ignore the result because we know it's a new line. And then we do the same thing. So that's what this separator is. And you can see that we actually have a separator between the callouts and the boards, and then between every board as well. So if we look at the board parser, so now that we've gotten the callouts, or the callouts, I didn't explain that, did I? The callouts are a separated list, separated by the tag comma, and they're all digits. So if we look at the callouts, it is a comma separated list of digits. That gives us a vec of string slices here at line 111, which we then use later on to return. So we get a vec of string slices. We use the separator to get from that to the boards. When we're in the boards are separated by the separator as well. So they're separated by 2 new lines. And then in between those, or not in between those, but as the entities that are separated by those new lines, we do a board. And the board is another parser, basically, that takes a string slice. So it takes the slice of basically the rest of the remaining input. And then the board itself is a separated list by new lines. So, right, we basically have this row and then a new line, and then this row and then a new line, and then this row and a new line. So we apply the row parser between new lines. And then once we get back each of those rows, we turn each of those into a board square. So we have the number for each of the columns in the row, and we have whether it was called or not, right? So we say that none of them were called because none of them can be called before we start the game. And then we create an ND array matrix, which we use later on. And then the row parser itself is just optionally a space at the beginning. So, like for example, 7 right here has a space at the beginning. And then we do a separated list. So all of the characters are separated by spaces, and we parse digits. So we basically have digit, space, and yeah, that's how we parse the input file. I really like nom a lot. I want to try to maybe improve this code a little bit, drop the heap allocations a bit. But yeah, I'm happy. We finished everything. I was going to try that sometime. It seems really nice. Can nom say where something is wrong in the input file? Yes. You will probably not do this your first time using nom, but there are 2 libraries that I would suggest. Nom Supreme. There are 2 libraries that I would suggest you look into for that if you do start using nom more. The first is nom locate, and this will give you a position in the file for what went wrong. See if we show an example here. Maybe it's in the README. Go back. You get to choose how to display this to the user, but basically, if you look at the nom locate README, you have this span type instead of a string slice as the input, and it gives you the location offset line and like the fragment and the column and things like that. So however you want to display that to the user in the end, you can, but nom locate is the package for doing that. And then there's nom supreme, and nom supreme will give you the entire tree of errors. So like if you have a problem in board 1 on column 3 in row 2, and you have an error in board 5 on column 3 in row 2, you have 2 different errors at 2 different places in the parse tree. Nom Supreme's error tree will let you keep both of those to be able to display both of them to the user at the same time, rather than just stopping on the first one. So those are the 2 things that I would suggest using, nom locate and nom supreme. They're both really great libraries. But that's going to call it for me for today. I am going to go take a walk to the store. See you tomorrow.